Okay, so for today's video, we get to use the classroom. I'm subbing today, so I get to use the classroom. So I'm using the whiteboard and I guess face reveal. So you don't have to ask for face reveals anymore, even though it's the first video. So in this video, I'm going to cover the inverse trig ratios. We're going to do a quick review of inverse tangent, and then we're going to talk about inverse sine and cosine, which, you know, they're not like super bad. It's just knowing about the situation and when to use them. But the thing about the inverse trig ratios is that there's like really only one specific way you can use them, and you need a specific amount of information in order to use them. They're honestly kind of easier with figuring out when to use what based on the information you're given. So to start, so as we know, we have our tangent function. We're going to denote some angle as theta. This is that little zero with the dash through it. And then we know that corresponds to the opposite side over the adjacent side ratio, not bad. And as we know, there's cosine of theta, and that corresponds to the adjacent side divided by the hypotenuse, and sine, which corresponds to the opposite side over the hypotenuse. Okay, we have our functions over here. We know what they correspond to. We've had a lot of practice working on them. And if you still need more practice, okay, but just for now, let's just assume that, you know, you are very familiar with this idea, you're very comfortable with these functions and what they mean. Now, for inverse tangent, we denoted it as this function, right? We'll just keep it like this for now, just to kind of keep it over here. So inverse tangent is some function. So typically when we're searching for some missing value, we're usually given the angle and we're usually given a side, right? So if we have a triangle, normally when we're solving for missing information about this triangle, right, we're typically given this some angle theta, and we're typically given one of these sides. We'll say that we're solving for the opposite side, we'll denote it as x, and we're given the adjacent side. Now, the inverse functions were meant as a way to use different parts of information, right? They were meant to be used when you're only given side measurements. So let's say that we actually know what the opposite side is, but we don't know what the angle measurement is. So the way that we would use our inverse function is that they would get rid of the main function. So in the same way that whenever we do algebra, right, if we have 1/2, we'll multiply by 2 to quote unquote cancel it out, but really we're just making this into 1, and anything multiplied by 1 is just 1. Or if we're like doing subtraction, or like we need to get rid of something, we'll do like 2 minus 2, right? That completely gets rid of those numbers because it's just 0, and anything added or subtracted by 0 will continue to be that same number, right? So in this case, the inverse of 1/2 is 2, and the inverse of 2 is -2, right? They kind of equalize in some aspect, depending on their operation. With functions, it's a little different. We have to actually create inverse functions in order to get rid of the existing function. So let me erase this and let's work with a quick problem. Say I'm going to erase these measurements and work with some real numbers. Say we're given that this is 2, this is 3, and then we'll just call this we'll keep calling this theta as some unknown thing. All right, when we set up our equation, it's going to look like this. Tangent of theta is equal to 2 over 3. Right? So this is our function, but we can't really, technically you could solve for theta. It's just it's gonna be like a bunch, like a lot of guessing and checking, or more so just checking. You'd have to like print out one of those trig tables and then go through it and then find like which angle corresponds to like this ratio over here. But instead what we're gonna do is we're going to apply the inverse tangent function. So it's gonna be, if you do one thing on one side, so we're going to apply inverse tangent, and that's tangent with a little negative 1 at the top. And then we're doing the same thing over here. I'm just going to give some extra space. So it's inverse tangent of 2 over 3. And then this inverse tangent and this tangent, they're essentially going to cancel each other out. So they'll equalize, and we'll be left with theta. And then on the other side, we have a new equation, which is tangent, or inverse tangent of 2 over 3. Now let me grab one of these calculators. It's going to be a little hard to explain specifically where it is on the calculator. I'm going to try my best. So hopefully this can be seen properly. So on the calculator, usually with these scientific calculators, they'll have like a bunch of like little numbers and stuff at the top of some buttons. So what you're going to do, obviously turn it on. You're going to press second, and then you're going to look for the tangent button, because typically with the tangent button right above it is inverse tangent. And you're going to press that, and you're going to get inverse tangent. Hopefully that can be seen on the camera. And then we're going to plug in our fraction, and that's going to give us that theta is roughly equal to 33.7. We're just rounding up to the 10th place. Yeah, so we'll say that theta is 33.7 degrees. And we could do this with the other angle as well. Right? Let's say that we'll call this alpha. So that's like the Greek letter for A, basically. It looks like a little fish. It's a little weird. So we'll do the same thing. Tangent of alpha is going to be equal to 3 over 2 now in this situation. And you could have just done some quick triangle angle sum and just solve for this one, but I'll show you how it is just like the flipped. It's just, it works exactly the same. We're going to do tangent of negative 1, both sides. And then we'll do just the tangent, not tangent of negative 1, inverse tangent, very top. And our tangent and inverse tangent cancel each other out. We're going to be left with alpha is equal to inverse tangent 3 over 2. We put our calculator again. So remember, we're going to press second on the scientific calculator. Then we're going to find the tangent button, which is going to give us the inverse tangent. 3 divided by 2. And we're going to end up with 56.3 as our alpha. 56.3 degrees. And just to do some double checking, right, we have our 90 degree from a right angle. We're going to add 33.7 degrees. And we're going to add our 56.3 degrees. Right, this is 90 over here, and then this is also 90 over here, which means it does in fact equal 180. Yeah, I'm just gonna leave this up on the board. If anyone wants to copy down. So we've shown that there's ways to find our angles, right, using the sides, and that's our inverse functions. So I'm going to erase all this now. Okay. Now, like tangent, cosine and sine also has some inverse functions. So let's work with them in these situations. We've already shown, you know what, let me actually write this on the side. We know that alpha is equal to 56.3. Wait, yeah. And then theta is equal to 33.7. So we'll keep that up there for reference, and then we'll use this side over here to help solve for some value. So let's solve for it real quick. We'll use Pythagorean theorem. 2 squared plus 3 squared equals c squared. I guess it's also kind of a Pythagorean theorem review real quick. So 4 plus 9 is equal to c squared. This is going to be 13 is equal to c squared, and square root 13 is equal to c. So we'll call this root 13 over here. That's also equivalent to about 3.6. Disregard that. Okay, we'll call that actually 3.6 instead, since it's actually a clean number. I didn't have to round anything, it was just like 3.6 like right away, with some zeros. Okay, so let's use cosine to solve for alpha. Now remember, we're going to set it up. We don't use the inverse function until after we've set up our main equation. So we're still using these equations, but we're setting them up first. So let's do cosine of alpha. So cosine of alpha, remember, alpha's over here. Cosine refers to the adjacent side over the hypotenuse. So it's going to be 2 over 3.6. Now that we have the equation set up, we're going to use our inverse function. So cosine, inverse cosine is going to be applied to that. Let's make everything green. Inverse cosine 2 over 3.6. Right? And just like tangent and inverse cosine and cosine, they're going to cancel out. That's going to leave us with alpha being equal to inverse cosine of 2 over 3.6. Now into the calculator, remember, we're going to press second, and then now we're going to go to the cosine button, which is going to have our inverse cosine at the top. We're going to plug in 2 divided by 3.6. You know, I didn't close out my parentheses here. Sorry about that. And that gives us about 56.25, which if we round up, gets us our 56.3. Now, that was for cosine. Let's solve for alpha using sine. I'll keep this over here, and then we'll also go do sine at the bottom over here. So we have our setup, remember? It's just the same setup, except now we're using sine, which is the opposite side over the hypotenuse. So sine of alpha is going to be equal to 3 over 3.6. Okay? Just like tangent and just like cosine, sine has an inverse function. Sine, inverse sine, it's going to be applied to sine to get rid of it. Now, it's a different math symbol. I think that was delta or epsilon. Okay, there we go. Here's alpha. So remember, we started off with our main equation, which was sine of an angle is equal to the opposite side over the hypotenuse. Sine of alpha is equal to 3 divided by 3.6. That's our opposite side. That's our hypotenuse. We're using the inverse function to get rid of the main function so that we can solve for the angle. And find that alpha is equal to sine, inverse sine of 3 over 3.6. We're going to plug it into our calculator. Remember, second, and then inverse sine of 3 divided by 3.6. And in this case, we get 5.44. So, you know what, actually, let me write down the numbers we've been getting. I'll put, so, this is our tangent numbers. And then I'll put our sine numbers, sine and cosine numbers over here. So we'll put cosine in this orange color. So cosine, and then we got that alpha was equal to 56.25. And sine is going to be in green, and this came out to be 56.44. And you'll notice that if you use a specific function to find angles, then it's they'll correlate, like, you know, like the values will correlate, they'll like match up, as opposed to like using different values and then seeing that, you know, there's some discrepancy over here. You know, this is 56.25, this is like 56.3, this is 56.44. But when we did find the theta over here, matched up perfectly with our tangent. So if we do the same thing with cosine and sine, you may see that they'll also match up perfectly. Okay. It just has to do with the the functions, they're set up specifically in the calculator, so they're gonna do things in a specific manner. Like they're really calculations themselves for the function in a specific manner where it gives different values, but they're generally in the same range of thought. Okay. So we're gonna do cosine of theta. That's gonna give us our adjacent side now is 3 over 3.6. We're gonna apply our inverse cosine to our cosine. Apply it to the other side. That's going to cancel out. That's going to cancel out. Theta is going to be equal to inverse cosine of 3 over 3.6. We're going to plug into our calculator. Remember, you're going to press second, then press cosine, and 3 divided by 3.6. So that's going to give us 33.557. So I'll just make that 33.556. Not 556, 33.56. Okay, and then we'll do sine. Remember, now that we've changed over to sine, our angle is now referring to something else. We're no longer referring to the adjacent side, we're referring to the opposite side. So sine is now going to be, sine of theta is going to be equal to 2 over 3.6. And then we're going to take the inverse of sine, apply it to sine, do the other side. Those are going to cancel out. We're going to be left with theta is equal to inverse sine of 2 over 3.6. You're going to press second, and then sine, and 2 divided by 3.6. That's going to get us 33.748. We'll call that 33.75. And if you might have noticed, on our right side over here, there's something very interesting happening. So I guess it only applies to tangent, where it just matched up perfectly like that, where we had that alpha and theta just magically coincide with each other. It ended up that when we did cosine and we found alpha and did sine and found theta, so we used cosine to find one angle, we used sine to find the other angle, they actually match up perfectly. Because see, we have 56.25 here, we have 33.75 here, and do the math. That's equal to 90. I kind of just wrote it out like that for no reason, but yeah, it's equal to 90. And if you notice the very same thing over here, you use cosine to find one angle, and you use sine to find the other angle. They match up. Look at that. Because this is 33.56 here, and this is 56.44 here. Those equal to 90. Just add it up together. So I guess if you really want to find complementary values, what you would do is use one of the trig ratios of cosine and sine to find one angle, and then you use the other ratio to find the other angle. Let's think about that. Why does that work out so much? Let's look at how the ratios are set up. So if we did, I'm going to have to erase all this over here, so you know what, actually I'm going to give a couple more minutes. Anyone wants to copy down, just read it through, absorb the information, and then we'll go make some of our little observations with the angles. Alright. So I'm going to erase this. Let's check this out. So we did cosine of theta, not theta, cosine of alpha, right? We had 2 over, not 2 over 3, we had the adjacent side, which is 2, over 3.6. Now let's do theta, right? Because this cosine of alpha, right, they gave us a complementary angle with sine of theta. Sine of theta, right, that's the opposite side over the hypotenuse. So the opposite side over the hypotenuse. Oh, would you look at that? They have the same ratio. They have the same ratio. And they spit out complementary angles. Let's look at the other one. We have cosine of theta. Now we're over here. That's 3 divided by 3.6. We have sine of alpha, right? Now that's 3 divided by 3.6. Look at that. They also have the same ratio. So there's some connections there. When these trig functions, they end up having the same ratios, right? They're going to have complementary angles when you're using the inverse function to find them, right? Because I'm going to put this in different colors. We'll put green for this ratio, and then we'll do orange for this ratio. Inverse cosine of 2 over 3.6 and sine, inverse sine of 3 over 2.6 . Right, so we had 56.25, and we had 33.75. And the same thing over here, green. Cosine of 3 over 3.6. So 3 over 3.6. gave us 33.56, and sine of 3.36, not 3.6. Okay, now this might be a little hard to see. Hopefully all of this has been really easy to see. I hope it's not bad. Is 56.44. Right? We're doing the inverse of the same ratio, and they're giving us complementary angles. Doing the inverse of the same ratio, just different inverses of the same ratio, and they're giving us complementary angles. So that's why tangent over up here, like it automatically is going to have its own, but like it's perfectly set up, because there's no other like version of it. Like there's only one way to do it. Whereas sine and cosine, we have a bunch of different ways. Well, in this case, 2 different ways to find the same angle. We have 2 different ways to find the same angle. Right? So obviously there's going to be sine and cosine are like very connected in the way, just because they have this hypotenuse at the bottom. So that creates a connection between them already. So, you know, there's some interesting connections over here. So when you start to solve for missing angles, you want to maybe keep that in mind. Maybe you should try using the same ratio, but just use different inverse functions to solve, and you'll see that values complement each other. I'm going to leave this on the board, and I think this is a good place to stop. We'll do a bunch of practice problems. Maybe we'll do a bunch of practice problems in the next video. But I guess the next video will be mostly kind of like a review and practice problems. Get ready for the test. But I hope this has been very helpful. I'll leave this on the board for a little bit, and then I'll cut the video. Alright. Hope you guys have a nice day. Please email me if you have any questions you need to ask me, or any clarifying questions or anything, or you want me to make another video. But we'll finish it here. Have a nice day. Bye.